All right, folks, welcome back to our course. We are on day 5 of the LLM Bootcamp 2, the Advanced Bootcamp. The topic of discussion is training, fine-tuning of models. In the earlier session, we talked about some of the more obvious reasons to fine-tune models or not to do that. We contrasted it with a RAG. We realized that it's not a this or that, but you can use both together. You can always do fine-tuning and RAG within the same framework. And in fact, I would advise you to, when not to fine-tune, when you have very sensitive data and you don't, and there's even a small risk that the LLM would be exposed directly or indirectly to the external world. All of those considerations. When to do fine-tuning, when you have domain-specific data, when your data distribution departs from the initial data that the machine was trained on, those are all good use cases for fine-tuning. But then emerged landmark work, which is the journey from transformer models. There were these transformer models. Birds were there. Last week was all birds in the bird family. Oh, by the way, speaking of bird family, that code also is all here. I just thought, okay, your textbook builder, as you notice, that solution is also here, right? And if you go to the bird family, you'll notice that I'm pretty sure we have posted text classification with Roboter using PyTorch. That also is here. So all the solutions are here. I thought as an aside, I'll just mention it. But then comes a reason to do fine-tuning that goes beyond just beyond the conventional reasons. It is the discovery of something that essentially started this big generative AI in the public consciousness. For the longest time, LLMs were the domain or the playground of researchers. There were a few thousand researchers, perhaps, playing with large language models, users, people who were using, and engineers who were using it for semantic search and for things like that, and different use cases, translations, this, that. But then came a fine-tuning approach that in many ways changed the world, radically changed the world. And that fine-tuning approach that emerged is the instruction-based fine-tuning, whose first, I suppose, real big use was in the paper, if I'm right, in the paper which introduced the instruct GPT. So it asked this question. GPT-3 was there, and there were other models and so on and so forth. And OpenAI had this paper in which they showed that you can fine-tune a model with text and ask it to predict the next word. Take a very simple situation. Go predict the next word. But if the data that you fine-tuned it on, if you structured it in a particular way, then remarkably, it developed the ability to have conversations in a much more human-aligned manner. Now, to set the backdrop of this, in LLM1, do you remember that we did the instructor paper? What did it say? When you create sentence embeddings of text, we use the same embedding for many, many things, right? Or for search, retrieval tasks, for question answer, for entailment, and so on and so forth, classification and so forth. So one of the early discoveries of the use of instruction was you would prefix the text before embedding. This is meant for search. This is meant for this. So then what would happen is it would end up, the same text would, because of the different prefixes, end up becoming different vectors in the vector space, in the latent vector space, right? And the empirical evidence was that it led to better each of the individual tasks, the downstream NLP tasks, whether it was search, whether it was question answer, whether it was classification, it would do better because now you had one class of vectors dedicated to that task, right? So people were realizing the value of adding instructions. The instruct GPT is a milestone, which is why this paper has the last I checked, more than 5,000 references, 5,000 other research papers have already referred to this research paper. Even though this paper is relatively new, it's just 2 years old. Its date pretty much coincides with the release of ChatGPT. Right? The first thing that popularized or that led to the democratization of the use of LLMs, we went from a few thousand researchers being marveling at the power of LLMs to a whole of humanity using these things, right? Or a significant proportion of humanity using these things now. Right? I don't know, does anybody have a statistics on what is the total utilization of all these large models put together between ChatGPT, Gemini, Cloud, and all of them put together? Is it fair to say that it's already crossed 1 billion users?
In ChatGPT, I was saying 180 million, 200 million range.
200 million range. Okay. So not yet 1 billion users, but hundreds of millions of users, it seems to be, right? And so let's imagine that Gemini and Cloud have smaller numbers, but somewhere in that figure. So we're talking about hundreds of millions, right? Not yet 1 billion, it seems, users using it. So remarkably, this transformation of a large language model from what it was in the classical NLP task that it was doing to something of general purpose use. There were many, obviously, breakthroughs that go into it. Any big breakthrough like a big thing like this has many fathers, and many big ideas go into it. But one of the crucial ideas that went into it came from a particular way of fine-tuning these LLMs with instruction. So I will give you guys a small introduction to it, and that's the only thing I'll do. In the afternoon, time permitting, I will carefully read the research paper, instruct GPT. We'll do a paper reading of that. But before that, I'll give you guys 2 exercises to do on your own. And I hope that you will do that. So let's see what we do today. What we do today is you do the so-called pre-training of an LLM. Right? Or let me just call it a language model. Language model. So for example, Bird2 is a language model, what we did last week. You get this pre-trained data. Give me a moment, guys. I would like to sit down. Okay. So pre-training, it's defining. So we'll put this word, many words together. Pre-training, fine-tuning, human alignment, prompt, and in-context learning. So there are many ways as we know today, that you can teach a machine to learn. The easiest is prompt today. We just prompt it. Now, why is the machine able to learn from prompt? It has to do with instruct, the topic that we are going to talk about today. Instruct. In a way, what you're doing is literally on the fly doing a mini version of an instruct fine-tuning, the topic of today. That's what a large part of prompt is, in some sense. Okay. It's because, see, the prompt in context learning would not be possible without the process of instruct fine-tuning that we are going to do, that we are going to learn today. So let's walk through this is the most inexpensive. Write your prompt, you're done. Right? Human alignment was done with RL, HF, but today we know if you remember, we covered the paper, direct preference optimization. So you don't need to do it with reinforcement learning. You do it with DPO. Well, things have gotten a little bit confusing because now people treat DPO as yet another method within RL, which is a little odd. But anyway, then pre-training is the most expensive because what you do is you scrape all of human public knowledge, scrape all of human public knowledge. Now, here is the fact with it. You say that is all very good. Where is that human public knowledge? Right? So there are open source projects like the Common Crawl that have scraped the web, and there are other things. For example, there is the Ayutha ML has created a thing called the Pipe. This is perhaps the largest repository of data publicly available for pre-training. And it's literally the largest. So when you access this data, I would strongly encourage you to stream it. Don't try to download the entire thing. Right? Stream and take as much as you need from that. But it's a remarkable thing that finally we have a data. For the longest time, all these big companies, they were saying, oh, we have pre-trained the model, but by the way, we are not going to give you the data we pre-trained it with. Right? The commercial companies are very cagey about their data. They don't quite easily give it. So, but now there are open source initiatives that are trying to remedy the situation quite a bit. But when you pre-train the data, when you pre-train a model, it is mostly unsupervised because it's very hard to create supervised learning. And by unsupervised, I mean exactly the way we talked about last time. It isn't truly unsupervised. We're not doing clustering and pattern recognition or dimensionality reduction. What we're doing is we are taking this text and somehow creating input-output, input label pairs. Right? So, for example, the mass language model is a classic way we do that. You take the cow jumped over the moon, the what jumped over the moon. This becomes your x1 and your y1 is equal to cow. Right? The answer, the word that you masked. So MLM is a classic thing. The other thing you could do is the next sentence prediction. You can take a sentence and the next sentence, and you can basically say, okay, what is the next sentence going to be? Right, things like that. So there are ways of next sentence prediction and so forth. Right, and then whether this sentence is really the next sentence to this as a classification problem or as a generative problem. There are many ways to train it, basically do unsupervised training. But
So
you
it's
have to
part of the foundational model.
Yeah, training the foundational model. Right? So pre-training gives you essentially a foundational model. Right? It is hugely expensive. You need a lot of GPUs. You need a lot of time. You need a lot of electricity. Right? It takes practically the amount of electricity a small town needs or a small city needs to power and train one of these foundational models. It's a massive environmental cost to it, carbon footprint to it. You put
Asif,
billions of trillions. Go ahead.
is there another example than masked language model for pre-training?
Yeah, next sentence prediction,
Got it. Okay, thank you.
and so on and so forth. So there are many that you use. So you can, and in some sense, we'll go through that exercise. In fact, that's today's lab is all about some newer things that we will learn. So at the end of unsupervised, you end up with a pre-trained model, often called foundational model. It's a foundational model if it can be used for a variety of downstream tasks. Now, so the history of this is people, for example, OpenAI had GPT-3. They noticed that they had an inkling that it's more powerful than it looked. Right? In fact, they were pretty hesitant releasing GPT-3. They eventually did, and later on they called it a mistake to release GPT-3. Okay? So they knew that it is quite powerful, and it is, well, their reasoning was also the AI safety aspect of it. So one problem though was that if you take these models, and well, obviously we can't download GPT-3, that would be too big, but you can download something smaller, like a 2 billion parameters Zephyr or Llama, something like that. Tiny models. Guys, play with 2 billion parameter models for fine tuning because it will actually fine tune on your 4090, right? On your GPUs or on your Mac Pros and whatever it is that you are sitting with. And certainly you can fine tune it in the campus because here we have a lot of 4090s. Right? In fact, at this moment, when I look at the size of the audience, we have more 4090s than there are people sitting here. So you can train it on that. And in fact, this lab you need to do on 4090. You can then, the second phase of it is you can fine tune. But if you look at the original model, you take GPT or something like that. Let me just take a pre-trained model without taking a name. Or maybe you take any one of these 2B models, 2 billion parameter models, which is practically what you would use. And you give it the question. Let's take the same old question. What is the, and this question, by the way, has been asked so many times, it's practically become the cliche or the hello world for this, to elucidate this point. I don't know whether it still does that, but it used to. What is the capital of France? And and because it is just a text generation engine, it's a causal model, it will come back more likely with what is the capital of, I don't know, something, let's say Germany. Right? That is not what you expect. What you expect is that it should come up with Paris. So the question is, how do you align it to, how do you now do further remediation to do it? So what you can do is you can give it a little bit more data, labeled data of sort. You can say, given this question, this is the answer, right? And that is when you specifically do that, it begins to respond to your so another way to look at it is sitting upon a vast amount of knowledge, right? It is the LLM is sitting upon a vast amount of knowledge. It just needs a little bit of hint on how to respond to your question. What way do you want to see your answers to come? And so you don't have to give a question answer for every question and answer in the world, right? So you can give it a training data. You say question, what is the capital? And you give it the answer. And you typically mark it with hashes, some demarcator. Are we together? You can do that. And so what people realize that you could do even further, you could give it a task, you could give it an instruction, and then you could give it 3 parts, input, and then you could give it the output or the answer. So for example, how would you, right? What color would you get? Would you get if you mix yellow and red? If you mix the below, and you could give yellow, red, and the answer would be orange. Are you seeing it? It is text going in. As far as the machine is concerned, it's a next prediction engine. But what it is noticing is, it is beginning to get, in some sense, conditioned on these keywords or these boundary demarcators of some sort. Right? It is seeing, or it is realigning the statistical engine inside to sort of align to the syntax. Are we together? Right? So go ahead, Sanjay.
The examples that we have taken, one is we switch the capital as the capital of France to colors, So I'm trying to see that the instructions that you're giving needs to be relevant to the question.
To the answer. The instruction could just be the question itself, for example.
Yeah, then how is it different from the one shot, two shot prompt?
See, the whole field of prompt emerged unless you train, unless you fine-tune a model with this. You take a normal pre-trained large language model and you try your prompting. Your prompts are completely useless. Prompts don't work at all. Right? So your one shot, few shot things, right? They are because you have done instruction fine-tuning of the model. Because prompts are nothing but literally instructions in these formats. You see that, right?
Sorry, I didn't get
Okay, so guys, listen to what I'm saying very carefully.
And then also you can say the importance of those activities.
Yeah. See, what happens is, imagine a large language model. It's been pre-trained on junk data. And I'm making it into a toy situation. All it can do is keep predicting the next word. It's a next word prediction engine. You train it on the world's scraped data. In the scraped data are HTML tags, in the scraped data are this hashes, in the scraped data a quiz list of quiz questions. You ask it, what is the capital of France? It remembers that I have seen lots of quizzes. And then it says, what's the capital of Germany? Because statistically, that's the best thing that it can emit. Remember, in that world, there was no such thing as prompting. Prompting is a consequence of instruction fine-tuning of a model. Right? It gave birth to the ability to prompt a large language model. You can take a pre-trained language model without this fine-tuning, you won't get anything out of it.
what would you get if somebody used the pre-train? What exactly?
You will discover that. In fact, that's your lab today. And you will realize the value of fine-tuning in the whole journey. And this was the significant breakthrough. The big breakthrough was this, that if you do, now what you do is you give it structured instruction in which you put boundaries, like you put some boundary, like this is common. People also do INST, instruction, INST, marking the boundaries of the instruction. Are we together?
So I have a question. Sorry.
Uh,
How universal are these across models? I mean, in these kind of instructions and prompts, are
It
they
depends on,
transferable?
yeah. See, the instructions or the hashes are completely what you fine-tune the model with. So when you fine-tune, you decide what demarcators you want to use. Right? Pick something that the machine already knows is some special character. Like so much markdown is there in the world. Markdown text is there. So if you pick hashes, that machine already knows that hashes are boundary demarcators, right? It will latch on to it. So it will reinforce that message. Whereas if you pick something strange, yeah. So for example, if you just give plain spaces, empty space as demarcators, it may not latch on to it as strongly. Are we together? So use something common, but whatever you use for fine tuning, it becomes accessible to you for downstream tasks. Does that answer it for you? Or?
Yeah. But thank you so much. But one thing I was always wondering about is, like, say, for example, if I take a wizard coder or a code llama, one of those, things for code to text, um, they've been already fine-tuned, like this was done by, they took Llama 2 and did something to it, and then they kind of forked off a Llama or wizard coder, right? So unless they expose that thing to me, I wouldn't be able to take advantage of how they were fine-tuned before I actually started using them, unless I did it myself from beginning.
That's right. That's right. So what happens is that all of these open source models, they come with copious documentation. And in fact, they come with the sample fine-tuning data. You just look at the structure of the data and you just change your input data, your data to match that structure. Unfortunately, there is nothing universal about it at this moment, right? It's a free for all. Every guy has a syntax. It's a situation like that. So look up the documentation. Somebody will use hash. Somebody will use triplet. Somebody will use this. Whichever model you're fine-tuning, do that. Now, people have created libraries to fine-tune. What they do is they remember that for some of the famous class of models, like Llama, there's that, what exactly is the nature of the instruction that was given to fine-tune it, and they do the conversion. You write it in one standard form, and they will do the internal conversion to that format and fine-tune it.
Great.
So it seems like this is instruction input answer is like question key
Answer.
value.
Sort of like that. It is like a question. What you're doing is, see, think of it from a machine's perspective. A stream of tokens are coming in. And what it is being told is that somehow if the question finishes, the instruction finishes, right? The next thing that it has to do should not look like a question, but it should look like the answer to that question, right? Yeah. That is it. That is the instruction. So when people did it, they realized, and so by the way, the world has gotten a little bit confusing because so many people speak about it. Theoretically, or more strictly, to train a model to chat, a chat LLM of any form, like say Chat GPT, you need 3 phases. You need to take a pre-trained model and you need to fine-tune that model. After you have fine-tuned that model, you need to also do the human alignment. Typically, initially it was done with reinforcement learning, and then recently we discovered direct preference optimization, which just makes it a form of yet another fine-tuning. Now, there are people, and this is where it gets a little bit confusing. Some people will refer to DPO, direct preference optimization, itself as a RL technique, right? Whereas if you look at the way the paper was put, it is that it's not RL, but in a way it has its own internal policy gradient. It sort of creates a one effectively. Then there are people who look at fine-tuning, and in fine-tuning, they not only mean this instruct fine-tuning, they also mean the human alignment, the reinforcement learning part also, right? So the vocabulary is a little bit fluid in this space, but I would like to distinguish between the 3 parts. First comes the pre-training, then comes the fine-tuning, and finally comes either the reinforcement learning or let's just call it human alignment, final human alignment, right? So in which you basically say, don't use offensive words and things like that. See, the fine-tuning will tell you what to produce, but you need some human alignment to tell it what never to produce, right? So you do have those stages also, but we will stop there. And I wanted to just say that and we will cover this paper in the afternoon. If you go to the course portal, you will notice that I have put a few things. I'll talk about it. This is the paper, Training Language Models to Follow Instruction with Human Feedback. You can read it, or if you get time, do that. There's also instruction fine-tuning for large language models, a survey. Remember, it is limited only to instruction-specific thing. There obviously GitHub has excellent collection of the awesome this and awesome that. So I picked up one of the awesome LLM fine-tuning GitHub repositories with papers and so forth. Go there. Now, I wanted to tell you about a few tools. XLLM. So what people have done is they have simplified fine-tuning down to such an extent that you can just use these and get away with fine-tuning. So in that space, XLLM, a couple of lines of code. Xolotl, you just have to write a script, right? Which you don't have to know Python itself necessarily for that. Run it from that. Then Uba Booga is lovely, and Patrick here loves it. And you can use Uba Booga to fine-tune, right? And this is particularly true if you're using LoRa adapters. Do you guys remember we did LoRa adapters in the LLM one? Right? We may not get time, or maybe we will get time to fine-tune a few LoRa adapters, but we'll see. When we come back to diffusion models, at that time we may fine-tune some LoRa adapters. Then one of the things I wanted to show is sort of out of place here, a little bit, but it's a very good thing. In Hugging Face, there is this, my URL is wrong. Okay. There is this set of I'll fix this URL. It's called the bloke. It's a Hugging Face space. A lot of the models are released by the bloke. especially quantized model. He's very prolific in releasing models. So I would strongly encourage you that you can just go with one of those models and start with that, right? Whatever you do, he quantizes it for you. He does so many things. It's hard to believe one person has so much time in the day to achieve so much. Right? Very prolific. So there is that. Yeah.
Can I ask something? With these three building blocks, so I'm just trying to visualize this. I know you're going to walk through the code, but before that, this particular tool, the low rank adaptation, and one of the LLM, how would those building blocks be talking to each other, just from a higher level view perspective?
See, at this moment, right, ignore the LoRa statement. It does. I can talk about the architecture, but that I'll have to revisit the whole territory of LoRa and how it works, how it sort of, it leaves. So here's a 1 minute summary. You leave the LLM frozen. You don't change its weights and biases. But when you fine tune the model, you actually let all the fine tuning happen in the LoRa, right? This tiny little model on the side, low rank adaptation. So what happens is low rank adaptation picks up the deltas, the small perturbations. And so it becomes additive because for every domain, like for history, for geography, etc., you can create one LoRa. And LoRa has been used as a fine-tuning exercise with great effectiveness. In fact, you don't need programming ability at all. If you look at stable diffusion and the way people have been using Uba Booga and many other tools recently, there is a LoRa. For example, you want to have a LoRa for lipstick on, a face. There is a LoRa for that. You want to grow a beard on somebody's face. There's a LoRa for that. You want to do something, color the hair gray, right? There is a LoRa for that. You want to put somebody on a horse. There's a LoRa for that. It's just endless. I don't know. Maybe I don't know about the horse one though. But okay. There's a LoRa for that people have created, and those are all within the purview of fine tuning. At some point, maybe I should give homework, a little project and a code walkthrough on using LoRa. LoRa, if you remember, Madhu, we covered the research paper, LoRa and QLoRa, in considerable detail in the last bootcamp. In this one, we will apply it. We'll do some code walkthroughs with it.
Got it. Thank you, Asif. Yeah, that answers.
Asif,
So-
I have a question. Do we have time for that?
Of course.
So, the HTML tags, where you separate like instructions. So, in one of the article that you shared with us about a candidate who won first prize in the ChatGPT contest in Singapore, she
Right.
mentioned that the LLMs respond very well when you use HTML tags, because basically they are trained based on the web scrape data, right? So I applied this. I just, in my system prompt, I say, hey, you're an expert, whatever. Then you have to follow everything in rules. And rules, I put it in HTML tags, and everything that I wanted the LLM to follow, I put it in rules, and it followed very specifically, right? It was very effective. So my question now is, intuitively, how different is instructive fine-tuning to a system prompt? So fine-tuning in terms of architecture perspective, we can say as adding a layer in the transform architecture, right? So how does, maybe you're going to cover it during the paper reading, but intuitively, I want to place this instructive fine-tuning in the space of where in a system prompt or the actual fine-tuning.
Yeah, good question. So let me answer that. Guys, see, that co-star paper that we did in the beginning of this said that demarcate, have clear boundaries, follow a pattern, an instruction pattern. All of that is possible and a consequence of the fact that you have fine-tuned your model using instruction fine-tuning. Because in the fine-tuning itself, you gave these demarcators, what it responds to, what it generalizes from that is that demarcators matter. Not only hashes matter, but all demarcators are significant. Are we together? And so when you use, it knows that HTML is a demarcator. And so it becomes sensitive to all demarcators. And that is the message of fine-tuning. When you fine-tune models, these models generalize. The machine learning is the ability to generalize. They generalize beyond your instruction, and they pretty much they figure out what is it that you're driving at.
So that's the reasoning capability.
That is what we feel. And that's why some people like Jeffrey Hinton feel that these things are reasoning, they're understanding, right? Because that generalization is probably the definition of understanding, right? So again, I'll iterate, because if you want the ability for your prompts to be able to achieve anything, or for example, that CoStar framework or any framework of prompting, systematic prompting, it works because you do instruction fine-tuning of GPTs. If you did not do that, it would not be possible. Right? It's a direct consequence of this training.
So fine-tuning this kind of data is mostly manual creation, but people sit down.
Yeah. No. So yeah, let me address that question. I'm sort of coming to that. Krishnan asked this question: how do you prepare this kind of data? Right? There are many ways of doing it. Right? Obviously, OpenAI sat and had the data labeler do that. What you do is you use another model to convert text into questions. So if this is the answer, what is the question? You realize that, right? And Stanford Alpaca, for example, they literally use ChatGPT to do that conversion and create test data, fine-tuning data for it. I think at some point, ChatGPT or somewhere OpenAI put a clause in their usage rules that you can't use it to prepare test data, but everybody does it anyway. Right? You always use a larger model to create test data to train smaller models, right? Instruct data. So fine-tuning data, often you create like that. The other is you use rules. Other is, I mean, you take tabular data from a SQL database, convert it to question answers. You scrape the web for FAQs. You can do many such things, and you can get your instruct data, and you do that. So guys, I will, this is a paper we're going to cover in detail. Sanjay, go ahead.
Sort of touched upon it, but then when we use the OpenAI model, we do this kind of prompting there. And you're saying that the model that we used was not just foundational pre-trained, but also.
Yes, absolutely.
Now,
So,
if you take that, then the reason to do fine-tuning is because we want to train it most likely on a data distribution that's outside of the common data distribution, which is more likely
no, that was one reason,
data.
Sanjay. That was one. So let me pose that question to you.
My question is, we have to do this, then it's like a big strategic thing that we're going to come up with more. Large data set to train like this. Like you can't just use the proprietary data and feed it into the model. Modify that to be in this pattern.
Yes, you do have to do that. So Sanjay's question is that if we have to fine tune a large, first of all, is ChatGPT the consequence of instruct fine tuning a foundational model? Very much so. In fact, the journey from GPT-3 to ChatGPT is the journey of instruct fine tuning and of course RLHF after that, right? Instruct GPT was the breakthrough, key breakthrough in the journey, right? Instruction fine tuning was a key breakthrough. That's why we'll cover that paper. The other question is that if I want to fine tune a model in my own in-house, then I have a strategic plan to create label data. Yeah, as you will realize, most AI companies are basically the grunt work is there in this field. There's a lot of grunt work. You have to data preparation is a big grunt work. So, okay, guys, I hope you get the gist of the idea, and you also get a clue on why prompting or structured prompting is possible, or why one shot, zero shot, few shot learning is possible. It all comes because the models have been sensitized to structured instructions, isn't it? Not random text, but structured instructions. That is what makes possible all of those things in these large language models, especially the chat variety of models. So I would like to give you guys two tasks, guys. I've been talking for a long time, and I'll take a couple of hours break after this lunch break. In the lunch break, I want to do two things, guys. First is there is a do thing and there is a learn thing, right? The do thing is quite, now let's get back, and please do it, because this particular batch is a little bit, should we say, oh, I didn't do that. Okay, I have to put the link here. Please go to the Hugging. Oh yeah, by the way, this is it. Toby, the blog. Oh, it opened up. Why was it not opening up? This is it. The blog. This is a very good source of models. He keeps producing a lot of very good models. So guys,
he has been stagnant after joining.
Yeah. Oh, he has been stagnant.
Yeah, he has joined some startup at one place.
Oh.
There are no models coming
Yeah.
out.
Poor guy. His public presence, his prolific activity is gone. He's joined a startup. The lure of, I suppose, millions is too strong. So, 1 second. Let me just show that. Guys, I'll take questions now. So guys, this is the homework. Let me just quantify the homework. I'll take everybody's questions now. Go to the transformer doc, guys. I'll post this link. It's very simple. Hugging Face, transformers. Let me post it instead of doing it later. I will post it to the website itself. If you guys please bear with me for a moment, I'll do it right now. I will add it as an assignment. So as you go through the tutorial, you will get code. Run that code, guys, in your Visual Studio. Use this to develop fluency with fine tuning using Hugging Face. This is it. The Hugging Face using document and then the associated code. Hugging Face. Docs are this, and is that just index? It seems to be. And I will mark it as a please do. And I'll give you the projects that I'm going to release. I'll explain those projects. So those projects, the two projects that I'm giving, please do it with Hugging Face. Are we together? Using the Hugging Face. We have already done training the model with PyTorch. Next level of abstraction, do it using Hugging Face. And then today I'll also introduce you to fine-tuning, instruct fine-tuning the LLMs. That too will be a project. And so you're going to do this. Let's go back here. If you go here, you will notice that there is a fine-tuning section. Where is it? Fine-tuning a pre-trained model. It's a very short section, right? It is very well documented. All you need to learn is the trainer API, right? And it's lovely. This API is lovely because if you notice, if you take a model, you can even ask for the tokenizer, the text to be broken up and tokenized based on that model. Right? It just simplifies everything down to a level that it is hard to even. It's just dead obvious. Right? How would you fine train a model? So go fine tune this. Learn about this fine tuning of the model. Do it only with the PyTorch. If you are adventurous, you can try out the TensorFlow approach also. But I do expect you to try it out with PyTorch. Right. The second thing that I will do is let me announce the projects for you, which you can do, not now, but you can do. Well, okay, let me, before I talk about the project, let me give you the second part of it. Do the fine tuning assignment. Please do it today itself in the afternoon. And I will do the paper reading only if I feel reasonably many of you have completed the task. The other is, and today itself, if you don't do it today, you won't do it. There is a very nice short course on deeplearning.ai on instruct fine tuning, right? Fine tuning of large language models. I want you to, this course is free. I like this course very much. And I want you guys, one of the nice things about this course is it will take you about an hour to watch the videos and perhaps an hour to play and do the assignments and things like that. I want you to please give today to instruct fine tuning. It's really well done course, right? So I was going to take you guys through a similar journey, and then I realized that I had no way to improve upon what she has done. So let's go with that. Right? These are the two assignments for today. So we are going to give lunch break in the next couple of hours to that. Around 4-ish, we will do the instruct paper reading. By the time, because you have watched taken the course from deeplearning.ai on instruction fine tuning, you will actually find the paper when I explain very easy after that. Right? You will have the context to understand that paper. So please do that. And when you do that, you will feel today, hopefully, if you do all these exercises, that you got the hang of fine tuning. Fine tuning is straightforward after that. Do that. Go ahead, Albert.
So how do you get to the first one, the hugging face thing?
I put the links here. Day 5, fine tuning LLMs. If you look at it, day 5, everything with day 5. See, I prefixed all the sections with days. So let's go to the course portal. This is the course portal. This is how you see it. Right? Do you notice that it is day 0, day 1, day 2, day 3, day 4, day 5? Right. And by the way, the solution to the BERT exercise is right here. So you have to go back to day 4. I thought I'll keep things in one place. Here is the text classification solution with Roberta that we did the last time. Then this is the textbook builder solution. Then this is the day 5. The solution of the PyTorch exercises that we gave are here. Fine tuning. This is what we are doing today. I'm giving it to you as a exercise to assignment to do. Please do it. Right? And see, guys, no amount of listening to me will make you skilled at it. Skill comes by doing. So please do it. And please do take this course, all of which you can finish in 2 to 3 hours. We will continue, we'll end the day with a paper reading at 4 o'clock, right? After that, at this moment, it's already 1:30. So we'll do the paper reading at 4:30. I'll give you guys 3 hours because I've timed it. That's what it takes, right? This is what you'll do. I will just take 20 minutes to explain to you the 2 projects that you have to do using Hugging Face. Are we together? Using Hugging Face. And next time, I'll release a project of instruction fine-tuning, but let's do one thing at a time. This time, learn about instruction fine-tuning. We'll do a project later. But this week, you must do 2 multimodal projects, which I will talk about now. And you will find a detailed write-up on that, like on your portal for both of these projects soon, right? A proper, well-documented write-up of the project. So project 1 are about trees. And project number 2 is about this, barking dogs and birds. So what is the tree project? Now, once again, it's a little bit, again, about the data. I would encourage you to, data gathering. Gather 100 high quality pictures of weeping willows and pepper trees. I've taken trees that are very common all around you. If you just walk out, it would be hard to miss these. Right? They're all in your neighborhood. When I say gather data, I ideally mean take your own pictures. But if you don't want to, take your own pictures. Right? Now, it's hard to get engineers to go create original data. So this is a high bar. If you really can't do it, then just scrape the web and get high quality pictures of weeping willows and pepper trees. Then use Hugging Face fine-tuning API to train a visual transformer, fine-tune to train. But by the way, I should say a fine-tune because training a pre-trained model is fine-tuning. To fine-tune a visual transformer to classify between weeping willows and pepper trees. Right? Now, guys, remember that weeping willows and pepper trees are part of the ImageNet. So out of the box, your visual transformer will be able to classify between these two. So your job is to make it better. Are we together? If you feel that you can't make it better, pick anything of your choice. Pick two different types of flowers, or do whatever you want to do. So for example, the plant detection or the flower detection is actually not very good at this moment in out-of-the-box models. Go pick two different varieties of flowers in your own garden. Take lots of pictures, or just walk over to a botanical garden nearby. Take lots of pictures, do that. Or, of course, the lazy way is to just scrape the web and get those pictures and do it. Don't use Stable Diffusion to generate. Yeah. Right. The other project, so this picture is, as you know, in the vision side of the project, vision model.
Asif sir, this project is specifically to use the Hugging Face API, right?
Hugging Face API must be used.
Okay.
Right? Use Hugging Face API, must use Visual Transformer, right? The barking dogs and chirping birds. This is actually an interesting project that was done by one of our interns last summer. And the project, and I'm giving you guys the same project because I felt he learned quite a lot by doing this project. Once again, get your data, and you will struggle with the data. Try it out. If not, I will release the data, but I don't want to because I want you to learn the pain of finding good data. Get barking data, dogs barking, dog barking, sounds, sound files, right? And bird chirping. Oh, and those of you who are cat lovers can replace dog with cats.
So you get many cats.
Files. Create these two files. So this is an audio fine-tuning project. These are pretty simple projects. You'll be able to do it. Right? Now, vision, we talked about the vision transformer. If you remember, in the LLM one, we talked about 16 by 16 pixel. Do you remember that we talked about the visual transformer? And then from there, we did the swing transformer, the sliding windows, improvement over that, and hierarchical, and many other things. Take your pick. The point is to learn fine-tuning, do a lot of exercises in fine-tuning. And we are not doing instruct fine-tuning, we're doing this classic fine-tuning to do that. The next thing is do the same thing with audio. Now the question is, how do we do it with audio? The answer to that is any audio sound wave or any kind of a time series way can, through a Fourier transform, convert it into something called Mel spectrogram, into an image. The idea is very simple. Take a small segment, see what frequencies there are and how much of those frequencies there are, create a vertical heat map of those frequencies. This axis is frequency, this axis is time, and in a time segment of 30 seconds, you keep on taking the slices and coloring it, and what you end up with is a color heat map diagram that is called the Mel spectrogram. Mel spectrogram. Those of you who come from information processing background, of course, are very familiar with Fourier transforms and spectrograms. But those of you who are not familiar with it, it's actually dead simple, nothing to worry about. And there are libraries that will do it for you in a line of code, a couple of lines of code. So what it does is it converts the audios into visual files. Once it is visual, you can connect the dots from there. Right? You can write a classifier from that. It's an interesting project. Please take it seriously. And I would hate to be the first one to, release a solution and realize that nobody has tried or nobody has done anything. Because then all you are doing is gathering a library of solutions. So these are your two projects, guys, for this week. Please do it. Not for today. It's not for today. It's for this week. So what is the assignment for today? The assignment for today is Hugging Face. Walk through the whole tutorial on fine-tuning. Do the exercise, like that code, right? Actually bring it into your Visual Studio Code. Run through it, make it work. And the second thing is take the deep learning course on fine-tuning, the deeplearning.ai course. It's a very good course. I was making notes on it and how to teach you. And then I realized that repeatedly it came back that in a way it has been done and I'm not adding more value beyond that. So why not just take you to that course? And it's free. After that, there are other topics that will come, but we'll stop here. Right? Take this. This is your next assignment. Complete the course on fine-tuning. This is the Hugging Face course. With those words, I will stop now and take a break. Are there any questions before we take a break?
I have.
Go ahead, Krishna.
So the lab session that we are going to do afternoon is about fine-tuning with our own data or sample data.
Sample data. Just do the Hugging Face exercise completely and do that course.
So is it going to be different from Instruct fine-tuning?
Instruct fine-tuning is the deep learning course.
Oh.
Deploying.ai course. So one is with just normal fine-tuning, and one is Instruct fine-tuning. And so I'm directing you to both of these learning exercises. And the point is, it's sort of a self-study. Go through the whole thing. Yes.
So you mentioned earlier that conceptually fine-tuning and pre-training, it's the same process, right?
It's a similar, it's the same process. Yeah.
But how does this work when you get those open weights? So does this mean this is the start?
Yeah, of your fine-tuning.
And then you can create any model after that.
Any model. The only thing, Patrick's question is when you get open weights for a model, and then if you were to fine-tune, it is basically training the model, right? It just so happens that it came initialized with those weights, open weights. Now, when you do that, there is one fear. See, when you train a model from scratch, there is no problem of catastrophic forgetting, right? The problem that happens with fine-tuning is if you fine-tune it with too much data and the distribution of this data is completely different from the previous data it was trained on, the more it learns the new thing, the more it forgets. Because it realizes that the old distribution was wrong, right? So if that is not the intention, if your intention is additive, then what you notice is the phenomenon of catastrophic forgetting. You didn't want it to forget the old stuff, but what it is learning is, oh no, this is not the way it should be. This is the way it should be. And all the weights are realigning and it's actually forgetting the past.
So
the pre-training.
How important is it to understand the data that was used from the initial pre-trained model that you're going to find?
Generally, See, here's the thing. People don't release their pre-training data easily. In fact, that's why I like the Pile project so much, open source initiative to do it. Still, you and I can't pre-train. But what happens is the distribution of the data, you should assume, is that of social networking data. Because most of these have been scraped off Reddit and this and that. And for example, Facebook is very happy. They are training their big Llama 3 model. Why can't they? Because they're sitting upon the social graph, the largest social graph of humanity.
How about the five? As of the textbooks is only need data, right? So that one's more academic.
That's more academic. No. The point of the textbooks is all you need. My research paper was not textbooks. It basically said that if you give it very high quality data, which is noise free, then even small models can compete with much bigger models.
But so that doesn't mean catastrophic forgetting because it's still based off of social networking information.
Yeah.
And then it's just processed further to be
cleaner and so on and so on. All right, guys. So with that, I will. Anyone would like to ask any more questions? Lunch is here. We'll take a 3 hours break, guys, because it will take you exactly 3 hours to finish it. Do that. It's 2 o'clock, a quarter to 2. So we'll gather in 3 hours, quarter to 5, and we'll do the paper reading. Fair enough, guys?
Yes.
Let's do that.